Okay, in our next video we're going to take a look at how to find the volumes of the solids of revolution by using what we call the shell method. Now the beauty of the shell method, let me move this up so you can get these notes down. The beauty of the cylindrical shell method is that it switches the variable of integration. So if you're rotating around a horizontal line, x-axis or a horizontal line, then y is your variable of integration. If you're rotating around a vertical line or a vertical line or the y-axis, then x is your variable of integration. And what you're doing here is you're finding the area, the lateral area of a shell, what we call a cylindrical shell, so a cylinder basically. So the lateral area of a cylinder is 2 pi RH. And what's going to end up happening is oftentimes the R value right there, that R value is going to be your variable, either x or y, and the h value is going to be your f of x variable or your f of y variable, depending upon what you're doing. The AP exam does not require you to know shells, but if you use shells correctly on the AP exam, they will not count it wrong. Sometimes it's easier to do. Like I was saying a few videos ago, when I test you on it, I will specifically say you have to use this by doing shells, or you have to do it by disc, or you have to do it by washers, or whatever. The 2 pi is a constant I pulled out in front of my integrand. So when I set up my integral, I'm having trouble with my Promethean board again. So let's go there. Let's go there, and then I can go down. Okay, so find the volume by shells. If you're rotating it around the x-axis or a horizontal line, it's 2 pi. The A value and the B value are going to be y numbers now. So that's going to be my radius. That's going to be my height. The radius can sometimes change if I change my center of the revolution. So if I rotate it around like 5 or -2 or 7, and you had to make sure this radius is positive here. In our last one, we did washers. If you let the radius be negative, that was fine. The reason why it was fine was because we're squaring it. But in shells, we don't square it, so you have to make sure that's positive. And then this is going to be the distance off the x-axis or off that center of rotation or whatever. That's going to be the height of the shell. If we do the y-axis or a vertical line, then x is my variable of integration. That's why it's dx. X is my radius, and remember we just, we could change the revolution. We could change where it's revolving around, and then it's going to change the radius a little bit. And then f of x, that would be your f of x is going to be your height of your cylinder shell. Look at a couple of examples. Okay, so in this first particular one, what I'm doing is I'm taking this graph of y equals x squared plus 1. And I'm bounding it from x equals 0 up to x equals 3, and I'm rotating it around the around the y-axis. So essentially, what happens is this. Let me just do one down here. If I were to draw a shell, this would be the inside, right there. That would be my height, right there. And the radius is how far off of the y-axis am I. That's my radius. That's my height. Okay, if I find the area of that cylinder, and then I just put infinitely many cylinders in here. So if I do another one down here, and I do another one down here, you get the idea. So I'm just finding the lateral area of these cylinders, and there's infinitely many of them. When I put them together, I get the volume of the shape. So in this particular case, 2 pi. I'm rotating around the y-axis, so x is my variable of integration. This is actually be a little challenging of a problem if you had to do it by using washers, because I have to solve this for x, and I had to consider both the positive square root and negative square root. So it's a pretty challenging little problem. But now, because I'm doing shells, I can use x as my variable. So my limits of integration are going to be from 0 up to 3. The radius in a given time is x, and the height is x squared plus 1, and it's dx. And that's it. That's all you're doing. Sometimes in the book, and sometimes I will on your tests and quizzes, I'll ask you to do it by using shells, or I'll ask you to use disc or washers. When I do it, I will specify that that's the easiest way. I will never make you do it. There's always an easy way and there's a hard way, and you have to decide which way is the easy way, which way is the hard way. When I specify which way you're doing it, that's always the easiest way to do it. I had another example. Oh, there it is. A couple more examples. Okay. In this next one, I'm going to give you kind of a wacky equation. Okay, this is going to be x equals 2y cubed minus y to the fourth, and it intersects here at 0 and at 2. And in this particular case, I'm going around the x-axis. Obviously, you can't take and solve this equation for y. So therefore, I have to leave the integrand this way. There's no other way of doing it. So I have to use shells. Because I'm going around the horizontal line, I want y to be my variable, I have to use shells. So it's 2 pi. How far off the x-axis am I? That's my radius. So they're y values for limits 0 up to 2. My radius is going to be y. And my height of my shell is going to be 2y cubed minus y to the fourth. And that's dy. In my next example, what I'm going to do is I'm going to take that center of the rotation and I'm going to change it. So instead of it being around the y-axis or the x-axis, I'm going to make it around another vertical line. And I'm going to rotate this shape. And this is around x equals 3, so a vertical line. So if I'm rotating around a vertical line, I want x to be my variable of integration with shells. This line is y equals x plus 2. This graph is just simply x squared, y equals x squared. And the reason why I'm doing this one is because now the center of the rotation changes, so now the radius is how far I am from 3. And I've got to make sure that's a positive number. Okay? X is my variable of integration. I'm going to use shells, so it's 2 pi times. My lower x value, I'm going to start rotating from here, which is over at -1, over to here, which is at 2. Okay? So I'm going from -1 to 2. And then when I do my radius, the radius is going to be how far I am off of 3. So it's 3 minus my x value. And you got to make sure that radius is, at any given time, you got to make sure that radius is a positive number. So I'm going to represent it as 3 minus x. If I did it over here on the negative side, you got to really be creative. You're going to have to go, instead of being like -3 minus x, it would have to be x plus 3. I'll do an example of that in class because I don't have one here. But if you rotate around a negative value, that does get to be a little bit complex. Make sure the radius is positive. So in this case, my radius is 3 minus x. And then the height is going to be not how far necessarily I am right off of the function. It's not like I go all the way up to x plus 2, because the bottom bound of my region is at x squared. So the height is this vertical distance. If you think about it this way, the height is always going to be parallel to the axis of revolution. So that's a height right there. That's a height that I'm putting in, and then if I were to draw a horizontal line from the center of the rotation, so I drew a horizontal line this way. That horizontal line, that's the radius. That's perpendicular to my axis of revolution. My height is parallel to my axis of revolution. I'm just rotating that around. So how far this radius is, that's the 3 minus x. What this height is going to be from x plus 2 minus x squared. That's the top of the region, that's the bottom of the region, and that's dx. So, I will clarify for you in class about the differences of when do I want to use disk and washers, when do I want to use shells. Sometimes shells are going to be easier. Oftentimes in the AP exam, they'll have you set up an integral to find a difficult region. They won't have you evaluate the integral. If you can use shells, it will probably be easier oftentimes. And they'll give you credit if you use shells, because a lot of people do teach it, but they're not required to teach it. So it's a good thing to know. And I will give you, when I do test you on this, what I'm going to do is I'll give you some problems where I use disk and washers, and I specify that. Some problems where I use shells, and I specify that. And then I'll use some problems where you have to decide. And I'll try to teach you. One of the things you want to do is learn how, like, when am I going to apply which one. And I think the biggest problem people face is the radius. When is the radius positive? When is radius negative? So just be careful about that. These regions should never be negative. These are volumes. The volumes are always going to be positive. Okay, so good luck with that, and we'll see you tomorrow in class.